Welcome to the very basic and fundamental course on mechanics of solids. So basically this course is very essential for the students who are studying civil engineering, mechanical engineering, aerospace engineering, automobile, architecture, construction, structure, and this kind of say field of engineering if you study. So basically this course is the bread and butter for them who are working with the solids, deformable bodies and deformable materials. Okay? So for them it is very essential to know the mechanics of those materials. Okay? So as we move forward in this particular course, basically we will see that how we can analyze the complete say deformable bodies or the material, and how we can model that thing for our intended purpose. So myself is Dr. Priyanka Ghosh from IIT Kanpur. So let's talk about the objective of this particular course. This course is to serve as an introduction to mechanics of deformable solid bodies, as I told you just now. The primary course objective is to equip the students with the tools necessary to solve mechanics problem. Okay? So if you want to know the physics of the problem, if you want to know what is happening, if you apply some force or moments in some particular material or the deformable bodies, how it will behave, how it will respond. So those things, if you want to capture, you need to know this particular course. Anyway, so the primary course objective is to equip the students with the tools necessary to solve mechanics problems, which involves the first one, static analysis of a component to find the internal actions, that is forces and moments. Second is determine stresses, strains and deformation due to internal actions. And third one is compare them with known acceptable values. Okay? So that means you have some deformable bodies, you are applying some force or moment, okay, that is the first step. Then you are analyzing how it will respond. Okay? So I mean, when you are applying some external forces or moments on some body, basically it will try to resist that thing with its inherent internal say force or internal say strength, right? So that thing is coming as stress, strain and all those things. So that is the response of the material, and then finally we will try to compare with the acceptable values. Okay? So this requires the familiarity with the vocabulary of the subject, skill of drawing free body diagrams, and the understanding of the material behavior under loads. Now these things are not known to you at this moment. As we move forward in this particular course, then you will be appreciating that what is free body diagram. So free body diagram is the backbone of this particular course. So once you know the how to draw the free body diagram of a particular system, then basically you will be appreciating that your problem will be becoming much more easier. Okay? So free body diagram is the basic thing and the backbone of this particular course. So I emphasize on this issue that whenever you are getting some problem, so you have to draw or you have to get the free body diagram of that particular system. So that is the basic thing for this course. So to understand the free body diagram, we will discuss more about this as we move forward. Okay? So it is expected to improve your engineering design skills. Okay? So it will, at the end of the course, you will appreciate that. I mean, if you want to design any body, say any structure in civil engineering, or any machine in mechanical engineering, or any aerospace structure in aerospace engineering, or any kind of say automobile structure made of say solid materials. So wherever you are going to design something, you have to have the knowledge of mechanics of solids. So this is the most important thing for you. So this is the grading policy. So the homework will carry 40% weightage and examination will carry 60% weightage. That is the final examination we will be having at the end of the course. And homework will be given on the regular basis. So, and you have to solve that, and based on that the marks will be awarded at the end. Okay. Now coming to the course outline. So, we are talking about the first thing we will be talking about in this particular course, that is the equilibrium of forces. So, here we will cover force vectors, moment of force, resultants of coplanar force system, free body diagrams, equation of equilibrium, friction and frictional force on flat belts, method of joints and sections for pin jointed trusses, frames and machines. Next is deformable bodies under axial load. So, here we will cover uniaxial loading and elastic deformation, statically determinate and indeterminate problems, force method of analysis. Next is state of stress. So, it includes concept of stress, normal and shear stress, equilibrium of differential element, plane stress, stress on any arbitrary plane, that is nothing but your stress transformation, Mohr circle principal stresses and maximum in plane shear stresses, absolute maximum shear stresses, and so on. Next is your state of strain. So, here we will cover analysis of deformation and strain components, plane strain and its transformation, Mohr circle and strain rosettes. Next is stress strain relationship and failure theories. So, here we will cover tensile test and stress strain curve, elastic stress strain relationships, thermal strains, generalized Hooke's law for plane stress problems, relation between elastic moduli, criteria of initial yielding, distortional strain energy, von Mises and Tresca yield theories. Next is bending. So, here we will cover bending moments and shear force, bending deformations, bending stresses, normal as well as transverse, built up, that is nothing but your composite members, deflection due to bending by double integrations and method of superposition, statically indeterminate beams. Next will be torsion, torsion deformation of circular shafts. So, we will be restricting ourselves only to analyze the circular shafts under torsion. We will not be talking about the rectangular shafts and other things, because those are the advanced thing. You will be getting those things in some advanced level course. So, this is the basic level course, try to understand that thing initially. So, this is the basic level course to give you the enough background about the mechanics of deformable bodies. Then we will cover torsional stress and angle of twist, statically indeterminate torque loaded members. Next is combined stresses. So, we will cover thin walled pressure vessels, stress caused by combined axial, flexural and torsional loadings. Next will be energy methods. So, here we will cover elastic strain energy, axial, flexural and torsional, complementary energy and Castigliano's theorem. And finally, we will cover stability. So, here we will include stability of equilibrium, elastic instability and buckling, column buckling and Euler load. So, this is mainly the course outline. So, we will cover all the things in this particular course, and I hope that you will be enjoying this course very much, and at the end of the course I expect that you should learn this particular basic course and the fundamental course in this kind of mechanical, science based engineering. Thank you very much.